This conference will now be recorded.
Hello, everyone, and welcome to the Satellite Book Club seminar series. The title of our talk today is Satellite Imagery Uses and Cases at the Ocean Prediction Center. Our presenter today is Chris Smith, GOES-R Satellite Liaison for OPC and WPC. And our facilitator today is Joseph Patton, Faculty Research Assistant from CISESS. A few reminders, we'll be recording this session as usual. Please mute your microphone and turn off your webcam if not already. Q&A will be fielded through the chat, and we encourage attendees to post your questions in the chat room. We'll field them from there. And as always, most of you are already doing this. Please sign in with your full names and specify your full names when asking a question so we can follow up with you should we need to after the meeting. Always looking for future presenters, contact the TowerS team. There'll be a link posted in the chat, and training team can help provide training materials that may be unavailable. Ross Van Til can be contacted for information or questions related to that. Thanks as always to OCLO, GOES-R, JPSS, and our facilitator today, Joseph Patton. Now, before we hand the microphone over to Chris, just a few words about Chris's background. Chris graduated from the University of Maryland with a master's degree in Atmospheric and Oceanic Science. His first role was as a contractor with NESDIS Systems Architecture and Engineering to maintain and update NOAA's user observational requirements that inform the organization's observing system architecture. In October 2023, Chris joined the Cooperative Institute for Satellite Earth System Studies, CISESS, as the GOES-R Satellite Liaison for the National Weather Service Ocean Prediction Center, helping to make satellite imagery and ocean products available to forecasters while also delivering feedback to the product developers to maximize product capability. Chris, welcome back to the Satellite Book Club. Take it away.
Thanks, Brian, for the introduction, and the TowerS team for inviting me to speak here today. My name's Chris. I work out of the Cooperative Institute for Satellite Earth System Studies as the Satellite Liaison for the Weather and Ocean Prediction Centers. Today I'm going to be talking about the satellite imagery and use cases at the Ocean Prediction Center, so I'm sure I'll be back in the near future to discuss the Weather Prediction Center. Next slide, please. So my role as the satellite liaison is to infuse satellite products, both GOES and LEO, into operations, mainly through AWIPS, since that's where our forecasters are drawing their analyses and creating their forecasts. And I serve as the R2O, O2R connection. What I mean by that is that I make developmental or experimental satellite products available to the forecasters and get their feedback and deliver that back to the developers to make sure those products are really going to be used in operations. I can also help coordinate with hazardous weather test beds to develop outlets for testing new products and provide training on how to use products. Next slide, please. So for an overview, the Ocean Prediction Center has very limited observations in their huge domains across the North Pacific and North Atlantic. So satellite imagery is really important for creating products and drawing analyses. The Ocean Prediction Center issues gale, storm, and hurricane force wind warnings, as well as heavy freezing spray warnings, do wind and wave and surface analyses, and issue high seas text forecasts and regional grid forecasts. So updating and verifying those forecasts relies on satellite imagery. Next slide. So the Ocean Prediction Center is using imagery for a variety of applications like fog and sea spray detection, tracing air masses to draw the surface analysis map and the wind and wave analysis, but there are more areas for opportunity that I'll talk about as well, like with sea surface temperature, storm structure, and convection. Next slide. So in AWIPS right now, we do have a lot of satellite imagery, all full disks coming in from GOES and Himawari, as well as Meteosat 10. We also have several RGBs for each of those satellites and GOES-derived products. We also have some polar orbiting satellite new caps from NOAA 20, NOAA 21, and METOP-C, scatterometers and altimeters, which I'll get into, and the VIIRS day-night band, where while most of these experimental products are accessed via the Cirrus slider. Next slide. So here's an example of the wind wave forecast. The Ocean Prediction Center recently went full basin on their 24-hour products. You can see the wind barbs as well as significant wave heights, or the highest 1/3 average wave height in meters there in the boxes. So verifying those forecasts are really important. Next slide, please. And here's an example of a surface analysis. It's a little small, but you can see there the various warnings that the Ocean Prediction Center issues are on that surface analysis map. You have a hurricane force low in the Northwest Pacific, storm and gale force warnings there to the east, and heavy freezing spray warning near that blue dotted area, which is actually the ice edge. And this was from early March. Next slide, please. So if we're looking at that hurricane force low that was in the Northwest Pacific, this is actually an ASCAP pass. We do have METOP-B and C scatterometry coming into AWIPS with its 25-kilometer resolution. You can get really a view of certain storm systems. I like to tell our forecasters to overlay the scatterometry over a grayscale image. This is the grayscale IR that was made by just messing with the color bar in AWIPS, but ProxyViz is another good option. And you can see here, there's those hurricane force wind barbs, those bright red south of the circulation. You can see where those winds are with respect to the circulation. And these are really important. Our forecasters use scatterometry about every day. Next slide, please. METOP-B and C, those scatterometer passes do follow each other, and then there's a gap for about 11 hours. So using some other wind resources are also helpful, and something I'm going to be working with our forecasters with. We do have several altimeters in AWIPS, Altica, CISESS, Sentinel, Jason, SWAT. They do have some limitations because it's a nadir looking radar for high wind retrievals, but still having something to complement those ASCAP passes with the big time gaps in between are really useful. You can see those very narrow swaths there. Again, I like to overlay the winds with some imagery in the background so you can see how close, the winds are to convection and things like that. AWIPS allows you to sample as well, so you can see the source of the altimeter pass and the time as well. Next slide, please. We also have the wide swath GCOMW AMSTER 2 winds from this microwave radiometer, the 36.5 gigahertz channel. Again, limitations with these for seafoam waves and convective rains, but with the wide swath, you can really get a picture of a whole system again, and this is kind of right in between those consecutive ASCAP passes. So you do get to see more wind data in between those long gaps of time. Next slide, please. So this is the wave analysis, still looking at that hurricane force low in the Northwest Pacific there. Again, these wave heights, significant wave heights, are in meters. So that 8.5 meter wave height is near 30 feet. So huge hazard to our mariners. And seeing these wave observations in real time can help us verify these forecasts. Very active North Pacific, which is often the case in early March. So we'll look at that hurricane force low on the next slide. And again, I like to have a grayscale image in the background because you can see these colored wave features really nicely. South of that circulation where we saw the hurricane force winds, there are wave heights near 40 feet. So definitely our forecast was capturing those large wave heights, and we're seeing wave heights that would be extremely dangerous to the mariners as the system moved into the Bering Sea. Again, you can sample and see the source of the altimeter and the time of the pass as well. Next slide, please. In our high seas text forecast, we are putting text in for visibility and dense fog. This one here was actually issued for south of Nova Scotia, Newfoundland, an area where you'll see more fog cases throughout this presentation. Next slide, please. One good option for viewing fog is the nighttime microphysics, especially because the fog tends to develop before sunrise. If you came to the Satellite Book Club in February, Bill Line presented a lot of good examples using the nighttime microphysics for detecting fog over land. Works the same way in the marine environment. We're going to be looking at box number 1 there, that dull aqua to gray color for detecting fog. Next slide, please. And this is from the Sierra Slider. We do have this in AWIPS, but going back to an archived case, I got this from the Sierra Slider. In that white circled area there, you're going to see that dull aqua gray color kind of advancing from Newfoundland toward Nova Scotia, and there's a town there on the tip of Nova Scotia called Sydney. And we're going to be looking at observations on the next slide to see if that dull aqua to gray color that's indicating fog is actually showing up in the observations. Next slide. And during that time where in the nighttime microphysics we saw fog moving in, visibility did drop to less than half a mile. So our high seas text forecast from the day before did verify. And when you can use one of these RGBs in tandem with any observations that we have, it really helps to maximize the situational awareness. Next slide, please. Sea spray RGB, this is something Bill Line from NESDIS STAR is developing, and to actually see sea spray in real time is a huge addition to our forecasting suite. We do issue heavy freezing spray warnings for ice accretion. In the Alaska region, it's 0.7 centimeters per hour. When ice attaches to a ship, it can become really heavy, causes things to lock up and even cause ships to sink. So this is really important to verify our warnings and for decision support services. I have the quick guide there on the right. Again, looking at a similar color, that medium cyan to gray color, it's kind of a milky looking color. And I'll show you some examples on the next slide of how to interpret that, but we're still building some case studies to see how we can use this in operations. Next slide, please. So here's a strong gale force low. This is in early May. We still do have to worry about heavy freezing spray that late into the spring. The blue dots, again, are the ice edge in the Bering Sea. And you can see that heavy freezing spray warning and pointing to those locations. We're going to be looking at St. Lawrence Island, which is that right red arrow there in the Bering Sea. Next slide. So this is kind of situational awareness of where you're looking. I zoomed in on the Sierra Slider. You have Alaska there in the top right and Siberia right in the middle, St. Lawrence Island down there on the bottom. And we'll have the animation on the next slide. I'll run through interpreting it. Next slide. Yep, there we go. So here's the animation here. St. Lawrence Island is really covered in the clouds, but just above that in the animation, you can see that milky gray color moving in the same direction as this broken up cyan color. That's actually the sea ice moving in the same direction as where that sea spray is. So we can detect heavy freezing spray is likely occurring there, verifying our warnings. Very important for decision support services. You can see more sea ice moving in the upper left image, and then those solid cyan areas that aren't moving where I pointed to Siberia and Alaska are the actual land. Next slide, please. The sea spray RGB isn't only useful for heavy freezing spray, though. We can see sea spray in other instances. So for this case, I'm going to be looking at a storm force low off the East Coast in late April. Pretty potent system this late in the spring. And if you go to the next slide, you'll actually be able to see sea spray from the Sierra Slider here. This was using the GOES sea spray. And you can see in the clear skied region near the bent back front, you can see sea spray. So again, that can cause reduced visibility and things like that, but also opens an area of research. If we don't have a scatterometer pass, could we potentially estimate the strength of a system just by seeing this sea spray, because it usually occurs when wind speeds reach a certain caliber. Next slide. So I'm going to get into some imagery for drawing our surface analyses. There's more than I'm presenting here. I just wanted to give another surface analysis map and show some imagery We're going to be focusing southeast of Greenland, a really elongated system here. You see a gale down to the south and a developing storm to the north in late May. Next slide. And one thing our forecasters really like to look at that we do have an AWIPS, but I grabbed from the STAR GOES viewer, is the veggie band. And you can see that gale force low is really easy to see there south of Greenland and the associated fronts. The ocean acts like a black body in the veggie band, and the land is very reflective, so you get a lot of contrast here to pick out features from the ocean versus land as well as the cloud cover. So this is a popular one for our forecasters in drawing surface analyses over the waters. Next slide, please. A few weeks ago at one of the satellite book clubs, we did discuss ProxyVis, and I said I'd be back to talk about it, so I will introduce it here today. ProxyVis mimics visible imagery at night by combining several infrared bands and doing a linear regression. It's very easy to look at low-level cloud features, especially over warmer SSTs, some that you can't see in the traditional IR imagery. So this is a really huge addition for our forecasters. Next slide. So again, forecasting low-level clouds and visibility, that's something we have in our high seas text forecast. This is actually a separate case. Still the same area though, fog was expected to develop again south of Newfoundland and Nova Scotia. Next slide. And in that ProxyVis animation there, in the blue circled area, you'll see this kind of stagnant gray feature. That is actually fog. I had the nighttime microphysics and verified as well, but I don't have it here. But if you compare that to band 13, the clean long wave IR, you don't really see those low level cloud features. So ProxyVis does allow you to do that. A couple other features to point out in the ProxyVis imagery that I didn't include in the IR are the fronts with the low level clouds are really easy to track. So this is useful for drawing the surface analyses as well as SST gradient. So that black arrow there in the left image is pointing to the Gulf Stream. This is important for our forecasters to know the location of. Systems do tend to track along those SST gradients and fuel and strengthen over that. So seeing that in the imagery is a really huge bonus for our forecasters. Next slide, please. We are also using RGBs for drawing surface analyses. The air mass RGB is a very popular one among our forecasters. I have the quick guide there on the right. Box number 1, seeing those dark oranges and reds are really helpful to see if a system may be strengthening or at least maintain its strength, because you have stratospheric air that's descending. It's very dry, has high levels of potential vorticity, and that can lead a system to strengthen. Next slide. So this case from late April, again, that storm force low that was pretty potent off the East Coast, that we could see the sea spray in the bent back front region. Next slide. From the GOES imagery viewer, we got a really nice loop of that. The system was in an environment with a lot of potential vorticity, so it explains why it was so strong late in the season. You can also see the frontal features really nice with this one and the different air masses as the system was pushing to the northeast. We do have this in AWIPS for all those satellites I mentioned, Himawari, Meteosat, and GOES. But again, this was an archived case, so I pulled this from NESDIS. Next slide. Thank you. This map's pretty busy, but we are part of the unified surface analysis, and one thing to see here are the low pressures and high pressures drawn all the way at the very high latitudes north of Alaska and Greenland. So seeing imagery up there is really important. Next slide. And Bill Line from NESDIS is also developing polar composites that allow us to do that. The NOAA 20 and 21 CRIS instruments are proxies for developing these air mass and water vapor RGBs like you see with the GOES satellite. This is really important because the VIIRS instruments don't have any water vapor bands, so seeing this is very helpful for, again, tracking air masses and frontal features for the unified surface analysis. We've also heard from the Ice Services branch of the Ocean Prediction Center, which is part of the US NIC, that they're using the water vapor and air mass RGBs to see where moisture and cloud cover could be, for looking at their SAR passes and determining the ice edge up at the high latitudes. Next slide. So I'll show you a real example of applying that RGB. This is another strong gale, the Bering Sea. Obviously, by now you've seen it's a favored location for stronger systems. You see that strong gale pushing into the Bering Sea. Next slide. And in the animation, if it loads, yeah, it's really clear to see that system. Again, those dark oranges and reds right near the center, high levels of potential vorticity, allowing that system to remain pretty potent as it moves into the Bering Sea. The IASI instrument will also be added to these composites soon, so you'll have the double amount of images. So this composite will look even smoother and really will be useful for looking at the high latitudes. Next slide, please. In our regional grids, we are forecasting for thunderstorms, so the ability to see lightning is important for monitoring trends if we need to update a forecast or just verify if our forecast is working out. Next slide. So that forecast was in early June for off the coast of Cape Hatteras, and looking at GLM, we do see that lighting up there, so our forecast worked out. This is from the GOES Imagery Viewer, and AWIPS I also like to overlay the GLM over geocolor just so you can see the background there and the convection, flash extent density really highlighting some more intense cells there on the northern and southern end of this region of convection. Next slide. So now I'll be getting into some products that are on the way that will be really useful to infuse into AWIPS and operations at the Ocean Prediction Center. One is the OceanSat 3 scatterometer. Again, scatterometers are like the bread and butter to our forecasters, very important. So having another one to complement ASCAT will be a really big addition. This is a KU band scatterometer. So ASCAT was a C-band scatterometer. This one's a little more sensitive to rain and it can be contaminated. Luckily, we're working with Tower S. They do have a rain rate parameter that we can help see the data quality. And there is a training at the end that I have on KU band scatterometers, so you can see some of the limitations there. Another bonus about this scatterometer, though, is that its swath width is very wide, so much wider than the 500-kilometer ASCAT. So you can really see a larger picture when you do get a pass from OceanSat 3. Next slide, please. SAR winds, we did have this in AWIPS before. We're looking to get those back in. From Sentinel, RCM, and RadarSat-2, these SAR winds have really high spatial resolution. A lot of times SAR's winds are task ordered from the Ice Center for the high latitudes to look at the ice edge, but sometimes you do get passes in our basins and you get to see a lot of detail for systems that you don't get from the 25-kilometer ASCAT pass. So this case was actually off the coast of Cape Cod, and toward the left side of the image you see those brighter colors. There's winds that are estimated to be up to 40 knots. So if we look at the next slide, that's actually the leading edge of this area of convection and thunderstorms, those higher winds just from that leading edge. That's something you can really see with the SAR winds data, and those localized areas are threats to mariners from convection. Next slide, please. Sea surface temperature. We do have some sea surface temperature data sets in AWIPS, but getting an anomaly data set like from OSPO would be really useful. Again, like I said before, systems do like to ride along those SST gradients like the Gulf Stream and the currents in the Western Pacific. But also this opens an area of research. How can we relate some of these anomalously warm SSTs, for example, this year to hurricane force low climatology and the number of hurricane force lows we're seeing. So having our forecasters be able to draw tracks over these SST gradients just to track features would be really useful in AWIPS. Next slide, please. We do also have AMSR2 RGBs in AWIPS, these microwave radiometers. We have 36.5 and 89 gigahertz options. And these RGBs allow you to see the precipitation structure of systems. Pink there is convection, and you can see ice in the convective clouds for the 89 gigahertz channel. And the blue are thick clouds. Area of research, again, seeing how that precipitation structure as systems transition from extratropical to tropical or vice versa. And I'm working with Michael Fulmer, our warning coordination meteorologist, to see how we can use this in real time for operations since it's already in AWIPS. Next slide, please. So now some future products. I did attend the 2024 Satellite Experiment Hazardous Weather Testbed as an observer. Lightningcast was one of the products that was evaluated and got a lot of good feedback. We do have this in AWIPS now at the Ocean Prediction Center. I have Lightningcast overlaid here on the channel 2 visible imagery. And this is the probability that GLM will observe lightning in the next hour. So this opens up a new door for our grids and, again, forecasting for convection. Could we use a product like this to inform mariners of where deep convection might occur and the threats that come with that, like higher wind speeds? You can see Lightningcast does a good job here with the deep convection that looked like it might have lightning. You can see the probabilities are really high there in the bottom left image. So this is, again, opening an area of research for us. Next slide. Same with Gremlin, GOES radar estimation via machine learning. This was also evaluated at the satellite experiment, and we've never had radar coverage before over the ocean. So again, this really opens up a new doorway for us, looking at convection, ways to alert mariners. Also with that OSCAT-3 scatterometer that can be contaminated by rain, there's ideas to overlay that over Gremlin so you can see where rain might be based on that simulated radar. So this is a product we're excited about at the Ocean Prediction Center as well. Next slide. I did have to give a plug to the TowerS Polar Planner tool. Again, scatterometers and altimeters really important for our forecasters. So knowing if that next ASCAT pass will be in your analysis or forecast is a question I'd often get. Something that you can now see with the TowerS Polar Planner tool, they also have other satellites in there if you want to know a new CAPS pass or anything like that. I'm trying to get our forecasters more familiar with this, but it's definitely super helpful for our operations. Next slide. So in summary, the OPC relies on a lot of satellite imagery and products, scatterometers and altimeters I've emphasized several times. Imagery and RGBs, we do have full disk for Himawari, GOES, and Meteosat, so a lot of satellite imagery is used here, but there's always more on the way, and figuring out what's the most useful requires collaboration. So please reach out to me if there are other products I'm not aware of, or if you saw some products mentioned that have different applications, I'd always be excited to hear. Next slide. So I did attach that KU band scatterometer training. This is from Comet, already developed on rain contamination. So in preparation for OSCAT-3, if you want to look at that. The Satellite Liaison blog, that's something I'm trying to post to weekly, alternating between the Weather and Ocean Prediction Centers, looking at impactful weather events and seeing the products that are forecast issued and what satellite imagery they used for the decision making. But I'm also trying to include newer or more experimental satellite products. So if you want to see your product featured, please reach out to me, or if you see something that could have a different application or you're wondering how either center is issuing warnings based on that, please let me know. If you have any questions, you can reach out to me there. I just want to thank the TowerS team again for inviting me here to speak here today, and I'll take any questions. Thank you.
All right, thank you, Chris, for that wonderful presentation. Lots of insightful satellite product uses were discussed. Just thank you again. I want to encourage attendees to please stay on for a discussion. Especially, we want to foster participation from field forecast offices and regional headquarters. And we also encourage everyone to change their view setting to active cameras. So there's that little button in the top center where you can view everyone or view active cameras. And if you select view active cameras, then you'll be able to see the two of us and then also people who may add on to the discussion. So Emily will now post a link to the Satellite Book Club feedback form. We encourage you to share any feedback you may have on this session or the SBC in general in that short survey linked there. I also want to mention that in a week from today, on Thursday, June 27th at 12 p.m. noon, Kelly Butler, a meteorologist from The National Weather Service Forecast Office in Wichita, Kansas will discuss the April 29th, 2022 EF3 Trino lessons from a near miss. So please join us next week as well. I want to encourage attendees to contact the TowerS team, including Kashad Bowman and Emily Maddox, for questions about the SBC or for configuration of any satellite products. And then you can also find them on the TowerS Slack channel. So now I'd like to begin our discussion section. So if you have any questions, please put them in the chat. And I have a couple questions here and a comment or two as well. So I'll get the ball rolling with this question. Chris, what other RGBs are OPC using to inform the creation of their analyses and products?
Yeah, thanks. That's a good question. Some other popular ones that our forecasters have looked at are the day snow fog. So looking at fog and low cloud cover versus snow cover, especially again at the higher latitudes. Day cloud phase distinction for looking at convection. Those are a couple of other RGBs that are popular in our operations.
Okay, great. I see we have a question here from Scott Lindstrom. Scott says, really nice job. Was that AMSR2 microwave image you showed really an RGB, or did the microwave image just have a color enhancement applied? If it is an RGB, what's being used for the red, green, and blue?
Yeah, Scott, that's a good question. I'd have to look back. It says it's an RGB and AWIPS, but I am pretty sure it's, like you said, a microwave image with a color enhancement applied. So it's something we can clean up.
All right. So I have a couple of questions here about ProxyViz as well. What other low cloud features are important for OPC to identify by using products such as ProxyViz? And are there any key differences between ProxyViz and the standard visible satellite imagery?
Yeah, thanks. ProxyViz, it's also important for on our surface analysis if we want to draw the location of a low pressure, seeing that circulation with the low clouds. You can see really nicely with ProxyViz. Yeah, so ProxyViz is, combining different infrared channels and using linear regression to look at, make it a proxy for visible imagery. So those IR channels are 2 kilometer, and then it's regridded to 0.5 kilometers. So the level of detail is a little bit different. With those IR channels too, you get some contamination from temperature. So sea surface temperature at the colder SSTs, those low clouds might not stick out as well as traditional visible imagery. So that's a limitation, but we found it is really useful for detecting where those sea surface temperature gradients are located, which is a pretty big perk.
Awesome. Yeah, that's good to hear. I have one more comment I wanted to add here, and then I also want to encourage other people to submit their questions in the chat. I recently worked on a project that used the GOES estimated rainfall, the Gremlin imagery, for aiding in forecasting heavy rainfall during Tropical Storm Philippe in 2023. Okay. And that was for impacts out over the Lesser Antilles. So the current literature that's been published on Gremlin only has really discussed it in the context of inside the continental United States. And so this was sort of a little bit outside their purview into that like open ocean area, which I know is more of a focus for OPC. Yeah. And I just wanted to throw in that the imagery that we had requested and created and used this in a forecasting workshop a few weeks ago with forecasters from the Caribbean, we saw that there was a pretty good, radar estimation based on the GOES ABI inputs, even out over the oceans. And I know that's something that they're working to publish actual literature on in terms of verification in the future. So just wanted to add that even though right now they're only testing it, they have only tested it on the CONUS regions, that it does have those out over the ocean applications.
Yeah, that's great to hear. I mean, we're always interested in the marine domain getting some attention in the training and verification. So seeing, how convection actually looks on there, if it's correct, is really important. Our WPC International desk Also does rainfall forecasting with the Hurricane Center. They're doing those rainfall outputs for the Caribbean and Central America. So that's, right, the Lesser Antilles would something they'd directly be interested in seeing the results of that for their forecast. So thanks for bringing that up.
Yeah, of course. I see we have a comment and a question here in the chat. Galena says, in addition to what Chris mentioned, a big difference between VIS and proxy VIS is that proxy VIS is available at nighttime, of course. And then also the question here, is OPC using SMAP and small SWINs?
I don't think we have those in AWIPS, Galena. I'm pretty sure, though, I could ask the forecasters any additional resource for looking at, those derived ocean surface wind speeds are a huge bonus. So that's something we can talk about. Definitely interested in that.
Okay, cool. I see we have a comment here from the Tower S team.
Oh, that's good.
Sorry?
I said that's good to hear about the RGB channels. Yeah.
Yeah. And then also Scott Lindstrom wanted to add that Gremlin is indeed flowing into the Pacific region and is actually in the Pago Pago AWIPS as of this week. So that's an exciting development.
Yeah, Scott had been messaging me about that. That's great to hear, another marine domain looking at Gremlin, so we can coordinate and collaborate and get thoughts from them as well.
Yep. So just going back to that comment that I think Lee Byerly posted, it says the center AMSR2 RGBs use the vertical and horizontal polarizations of the channels used. For AMSR 89 AV is blue, 89 AH is used in green, and the 89 AV and AH are used in the derived RGB on the fly and AWIPS for the red. So if anybody is interested in those recipes, you can reach out to the Tower S team. Okay, are there any further questions at this time? I don't see anything else in the chat. Oh, we just had a question come in from Michael. He says, are you and the OPC considering future products from GeoXo's enhanced capabilities, particularly the Ocean Color Instrument, OCX?
Yeah, thanks, Michael. That's a good question. We are interested in applications from the Ocean Color Instrument. Seeing, ocean circulations and gyres, things like that, are something we're interested in. I've talked with it's our applications branch chief who's coming on camera now. I figured you'd have something to say about OCX, Joe.
Yeah, I think, by the way, great job, Chris. And I hope for some of you that are terrestrially focused, you've gained an appreciation for how much imagery, how much satellite data is really needed over the oceans, and how much our own organization actually, those that have marine responsibility, especially over ocean areas, use. On the ocean color side, one thing we're really interested in is ocean features. And by features, meaning thermal boundaries, current gradients, because as we move forward in time and go to coupled modeling systems, that there are phenomena that occur on small scales where there are current gradients, surface current gradients, because of the interaction of waves and wind. We learned a long time ago with scatterometry that we actually, in the right flow regime, you can see the underlying ocean thermal structure manifested in the wind field that's derived from the backscatter. And that typically off the East Coast, you'll see it in a southerly flow, especially in the spring. It's an enhancement, but you'll see it other times. But there are wave interaction with current is significant we did a study several years ago looking at transits of the Gulf Stream by ships. And in that study, we looked at about 200 transits. And you could see basically
Oh, I think we might have lost Joe.
Might have lost Joe. Yeah.
and learn a little bit more about ocean color, and perhaps what it can
Yeah, Joe,
help
we have you, but you're breaking up.
uh,
Yeah,
in
it's hard to hear you, Joe.
identifying ocean features that actually play back into the atmosphere. Thanks.
Yeah, and I see the comment in the chat about how often forecasters at the Ocean and Weather Prediction Centers are using the CISESS slider. I'm using it a lot, obviously, for my blogs and archive satellite imagery. I know that the Weather Prediction Center International Desk relies on it almost every day. A lot of the experimental products that I introduced are forecasters. If they're one of our bigger satellite users, they might use that on a daily basis. Otherwise, it's definitely more AWIPS, but the CISESS slider is an important resource for us.
Yeah, and I popped on real quick if I could talk about that just a minute. So yeah, I'm the operations branch chief, Darren Fergursky at the Ocean Prediction Center. And it's really important, I think, for us to, be able to have access to the products in AWIPS right now, and AWIPS and AWIPS, because we rely so much on being able to see these features overlaid with other data to make our surface analyses, to make our long-term forecasts and things. It's really, it becomes much more difficult if we have I'll call it the kaleidoscope of things that we're looking at on the web, to be able to eyeball these things and how they reference themselves to, low pressure systems, freezing spray, hurricane force systems, and cold fronts, warm fronts, and the like. So while we know the online resources are there, and there's a lot of them, and we do look at some, it makes it important to have all of the data as much as possible in integrated workstations, so we can, really use them to their full capacity for forecast situational awareness and watches and warnings for the mariner.
Awesome. Thanks for that extra context, Darren. We appreciate that a lot. So it looks like we're coming up against the time that we have allotted for this presentation. So I want to thank everyone for their discussion and their comments. And I want to thank, of course, Chris for the presentation today, and the Tower S team for helping facilitate. So I will now pass it back to Brian for some final remarks.
Hey, thanks, Joseph, for your facilitation today, and thanks, Chris. We appreciate you and the Ocean Prediction Center bring all these cases before us, some of which I think we were aware of, other new ones that you've shown us, and applications far beyond OPC, many of the marine coastal sites, as I think Joe said, very interested in these. One thing we're always looking at is how close to shore do some of these products come. I know some of them are open ocean, but they don't necessarily come right up to the shore. So I'm interested in learning, not here and now today, but in the future, how Chris, you and Joe and Darren and OPC interacts with the coastal WFOs to have kind of a continuity across that interface. But really interesting talk. And thank you both for bringing it. As Joe said earlier, please join us a week from today, June 27th. Kelly Butler's presentation on tornado near miss should be exciting. And with that, wanted to thank all the organizers and participants, and we'll wrap up today's seminar right here. Thank you.